Okay, good evening. Thanks very much for hanging on for the last presentation of the evening. My name is Brian Carter. I'm currently working as a data scientist in IBM in Dublin, and there's some of my contact details. All the IPython notebooks for this presentation are up on my GitHub account for anyone that wants to download them. So previously to working in IBM, I worked for An Garda Síochána, which is the Irish police force. And this presentation is kind of an offshoot of a project that I worked on there. But I suppose it's kind of, when I was learning Python, I found when people put projects up on GitHub with the IPython notebooks, it was a really good way of learning it. And so it's a step through of how to do a web scrape and then an analysis. And I was delighted when the last presenter introduced the topic of drugs, because the web scrape focuses in on a website called pillreports.net. And this is an online database of reviews of ecstasy pills. And I suppose when you think about drugs in consumer theory, their experience... Okay. Is that better? Okay. So when you think about drugs in consumer theory, they're experience goods. So in terms of you don't actually know what you've bought until the time of consumption. And very like other review sites for restaurants or hotels, they can be viewed as a bridge between that knowledge gap in terms of people trying to investigate and find out what they are buying before they buy it. And some of the motivation behind this was it possible to identify where an identifiable pill is producing undesirable effects. So I'll just come out of here a bit. So, no. So this is an example of a typical review on pillreports.net. And this is called an Orange Dom Perignon ecstasy pill. And so there's lots of different fields associated in terms of the date it was submitted, where the report came from, some information about the logo on it, the size. And then typically the way people are interacting with the website is that they are putting in a description of the pill. And then there's two fields down the bottom where it's related to consumed and warning. And that's where it has somebody actually consumed the pill. And then when they consume the pill, they'll typically write a report about the effects that they have. And when the people are putting up reviews where they haven't consumed the pill, they're typically looking for other people to, in the comments section, to start giving them information about like the effects of the pill. So in this case, somebody says that reaction looks weird, or somebody else is saying, hey, I've taken these pills before and they're great. So here's an example of, it's called a yellow Instagram pill. And so they've provided a picture of it. And then the guy has provided like a report of like, after he's taken the pill, what's the effects that he's feeling. So like, I mean, at one stage he says, okay, I'm starting to get really high and I feel like touching my face and all this kind of stuff. So there's loads of really interesting information in the data. So the outline of what I'm going to go through, it's kind of a fun presentation, so it's not overly technical. I'm going to go through how I scraped the data, a little bit about the cleaning, some experiences doing data exploration, and then a little sort of some of the insights that I got out of the data that are quite interesting. So I'm using the URL lib2 package to connect to the web page, parsing with Beautiful Soup. And there's three pages, or three HTML pages of data in it. So when I'm connecting, or when I'm going into each report, I'm just checking if there are 3 tables and if I can. And so if not, I'm just rejecting the web page. And it's the Pillar Reports is quite a simple website. There's not much there's no dynamic content on it. Sometimes reports are pulled down by administrators because somebody puts in identifiable details in terms of maybe the nightclub they were in or a name of a person or something like that. So then once the data is scraped, I've set up a database in a MongoDB. And just in the format, because sometimes when you're playing around with this kind of stuff, you kind of might do a couple of scrapes until you get to the point where you're getting working. So the database is set up with the name of today's date, and then if every time I hit the MongoDB, if the database exists, I just drop the database and recreate it again. And So, and then it's very straightforward in terms of the tables. On the first column have the categories or the column headings. So I'm just reading that into a Python dictionary, using the first column as the keys and the second columns as the values. I do some basic cleaning at that stage in terms of removing white spaces and any extra HTML tags, and then insert the dictionary into a collection as a document into one of the collections in the MongoDB. So there's 2 collections in the MongoDB, one for the reports and one for the actual comments associated with that. And that actually works really well. It's very straightforward. The dictionary maps straight, PyMongo just flies at that. And it's a really nice way, handy way of doing that and collecting the information. So I'm not going to go into too much of the cleaning of the data. It's all the usual stuff in terms of renaming columns, cleaning up your date formats, some geocoding because the cities and towns are quite dirty and quite messy, creating some integers and then categorizing some multinomials and that kind of stuff. One thing I did do sorry, that's just connecting to the MongoDB and then reading the collection into the Pandas data frame. And that actually works really, really fast for doing that. So, so once you have it in the Pandas data frame, you can fly away with that. So one library I did use was LangDetect, and that's a Python port of a Google library for language detection. And it's a naive Bayes rule set, and it can detect 49 languages with 99% accuracy, having about 10 to 12 words, depending on the language. And I suppose I'm a native English speaker, so the reports can be in lots of different languages. So for doing the analysis, later on I want to filter by just those reports that are written in English. So that's kind of a breakdown of sort of where the reports are coming from, say the top 7. So the top country is the US, and the top language is English as well, with, say, 3 of the 5,000 reports. I did this on, I did the language detection on the user report field. Sometimes that's not filled out depending on whether somebody has consumed the pill or not. So the US is the biggest country. Ireland's not doing too bad per capita in terms of the number of reports that it's submitting. Where am I? So one of the things, so I work with lots of different tools when I'm doing data mining. And one of the things I suppose that was a steep learning curve for me is doing visualization in Python. So I kind of played around with a lot of libraries, and I was really interested yesterday to hear the different developments in the area of visualization with Bokeh and other stuff. So my experience in using Python for visualization, it takes a bit longer to get to the point where you want to visualize. And typically, for most of the libraries, you have to do the aggregation and the roll up outside before you feed it into the plot that you want to create. Whereas I suppose when you look at some of the libraries like in R, like ggplot and ggviz, a lot of that is sort of embedded in the APIs, and you can get to that point with a lot less code and a lot quicker. So this is just one sort of insight in terms of the number of reports that have been submitted to the website over the 2-year period. So you can see there's a downward trend in the number of reports. And so following on from that, then another thing I wanted to kind of look at is what's the breakdown between the number of reports where a warning is where somebody says that yeah, this pill is okay, so there's no warning attached to it, and somebody says yeah, I had a bad experience when I took this pill. And again, sort of this sort of as an example in terms of trying to create or getting to create a simple stack plot. You kind of have to go through a few jumps to get to the point where you want to show like the percentages and that kind of stuff in terms of creating arrays and all that kind of stuff. And I suppose, again, the insight here is that over the time period, the number of reports that have a warning equal to yes is shrinking. So that's kind of an interesting insight to find in the data that's going on. So then the classification. So the first sort of model, or sort of what I'm showing here, is just a very simple naive Bayes model, and using the description field as a free text field, creating the vector representation, and then using the warning label as the target label. And so I'm filtering the rows to where the language is English, and that's the distribution doesn't change in terms of, so there's about I have the labels wrong there. It should be 65% of all reports are no, and 35% of all reports are yes. So that's the setup for creating the vectorization and creating the model. I've used the pre-processing labeling encoder for the warning label to create that into numeric value. Cross-validation for the train and test pipeline, which is really nice in terms of if you want to try lots of different things, and you can wrap your pipeline in a loop and pick out your different models you want from a list and feed them in, you get a nice result. And also the pipeline allows for all your pre-processing steps, so you can repeat them then when you're doing that on the test data as well. And then printing out the training scores using the metrics feature. So that's just at a first pass with using all the features. You get the train and accuracy of 73% and 72% then for the test score. So then one of the things like that kind of you often try and do then is, okay, can I reduce down the features? So in scikit-learn currently, one of the implementations of feature weighting, or the calculating the variable of importance, is the chi-square value. So again, that's some of the code associated with doing that, and it's fairly straightforward. I'm using use the iter tools and compress here so I'm selecting the top 250 features based on their chi-score, and then filtering out my features based on these using the iter tools compress, and then creating a data frame to do a count over the words count split by the warning label. So for a particular word that is the highest chi-square score, how many, for a binary occurrence, how many documents does it occur in for the warning label equal to yes and the warning label equal to no? And so that's just a printout, or the breakdown. So the word black having the highest chi-score, and it's in for documents where the warning label is no, it's in 203, and for yes, it's in 27. And sort of one of the interesting things then, I kind of was like going, okay, what if I visualize this information and to see what that looks like? So I just feed that into a matplotlib scatter plot, and I hope you can see this. No, I mightn't get any bigger. So what you can see is between the yes is on the y-axis and the no on the x-axis, and you can see the separation between the two classes, and the points are sized by their chi-score, the relative chi-score. And then I also coloured the points by stop words. So sometimes when you're doing analysis using text, you can there is a set of English stop words, and you filter them out, and then you go, okay, my model's gotten worse, or that kind of stuff. And so a lot of the stop words have a high chi-score, and that's because they feature in phrases in terms of, so a phrase associated with a warning equal to yes is stay away, and away is an English, in the given set of stop words in the NLTK package, away is one of the stop words. So it's kind of a thing like to sort of be conscious of in terms of when you do filter out words, how that can impact. And then of course you can create like bigrams as well, like to combat that. But then you increase your feature set as well. And so this is just a zoomed in plot of the same information. And what's interesting here is that you start to get an insight into some of in terms of like the domain knowledge and insights into what's going on there. And it's probably very hard to see here, but some of the words that are associated with the a warning equal to yes is stuff about taste and sour and different stuff around that. And in terms of ecstasy production, the current model is in terms of sort of on a global level is prohibition, and so as part of that, a lot of countries have prohibited some of the chemicals that you use to make ecstasy, and one of them being saffron. And a very similar type chemical that you can use is aniseed oil, which goes into the manufacture of MDMA, but actually produces a different drug called PMMA, which has similar effects as ecstasy, but is more toxic and works in a different way. And so when that's kind of the resultant pills do have a sour taste, and so you're seeing that information being bubbled up there in the users equal to, or when people are have a report and they're saying there actually is a warning or they've had a bad effect with those pills. So then another kind of interesting or fun thing I was decided to do is like look at the user report field, and that's where somebody has consumed a pill, and see is there any kind of nice interesting stuff that we can look at in that aspect. And so I filtered the rows to where the language is English and just some of the top countries in terms of giving in reports. And I wanted to see as well, maybe there was a difference in the type of language that people used in different countries. And then, so the way I kind of went about it was to look at creating, or I created a binary vector representation of stemmed words and normalized it, and then 378 features, and then performed PCA with and the first two components of the PCA explain about 3.5% of the variance. So one of the things in PC or currently in scikit-learn, I'm not sure, it might have changed since I've done this, is that the sparse matrix representation, you can't actually do PCA in scikit-learn, so you have to convert your sparse matrix into a regular matrix when you're doing that. So, and then basically I do this all the time, is creating a scatter plot of the components and then overlaying the nominal values and see, like, is there any interesting patterns in that. So this is a bit like a Skittles chart. So this is, it's the same plot over and over again, written or done in matplotlib, and then overlaying different nominal variables. So the first one is just a k-means clusters with 3 clusters in it. I didn't really investigate in terms of what those clusters are. The second one over to the right is the points are coloured by the length of the document that's gone into it. So you could kind of sort of make the argument that the first principal component is capturing some of the information related to the lengths of the documents. This chart here has the points are coloured by whether the warning label is no or yes. So you can see there is good separation between the two classes there. The next one over is looking at the suspected contents. So in terms of whether somebody believes that they have taken a pill that contains MDMA, or it's an unknown, or they've taken something that they believe has amphetamine or piperazines and all that kind of stuff. So you can see there is kind of a sort of a very visual pattern there that you can see that MDMA is more associated with the red points here on the left, which are the labels equal to where the warning is equal to no. And then some stuff, it's very hard to see on this screen in terms of colouring the points then by the country of origin. And there's some, you can see some separation there on that. And then by weekday as well, there's not really much in that. So then the sort of the last thing then, I suppose, when you're looking at text data is you have to do the obligatory word cloud. So this is just pulling out the reviews from the in the user report field and applying NLTK for the word tags. And then I've just sort of said that adjectives and nouns are rich words. And then plotting up or using a word cloud package that was developed by a guy called Andreas Müller. Then just like literally surfacing up the word cloud, which is just like the word counts, and splitting it up by whether the person believed that their suspected contents were MDMA, amphetamines, or unknown. And it's kind of interesting because you kind of get some of the information. When somebody takes MDMA, they're using words like love and euphoric, and then some of the physical stuff in terms of like their eyes rolling. When people are have taken what they believe to be amphetamines, the words they're using are much more surrounded by rush and sleep and awake and that kind of stuff. And then the people who have taken pills where they don't know what they've taken, you get much more focus in on, say, the negative physical effects in terms of feeling sick, the taste, weird, sure is unsure, and that kind of stuff. So that's my presentation. I hope you found it interesting, and if you have any questions or comments, please. Yeah.
Hi, very interesting presentation. My question would be, were you able to make any suggestions about the provenance of these drugs based on that? If you look at these, you say certain words occur, so I guess at the end of the day you've got different groups of the pills. We're using these groups, are you able to say, these 5% are maybe coming from a certain supplier, or these 10% from another one? And what kind of statistical methods, or what was your methodology for doing that? And did that have any impact on investigations or anything like that?
Yeah, I suppose like in terms of when I started the project, I was working in the Irish police force, and I subsequently moved jobs, and it kind of turned into a more fun type of project. So in terms of that, there is like, I think there's in terms of that data set, there's probably a lot of work that can be done in terms of categorizing, because there is branding associated with ecstasy pills. but there's no, you don't buy it with a package and a name sort of thing, but people are putting names up there. So there's probably a lot of work that can be done in terms of taking I didn't do anything with the images or all that kind of stuff to see if maybe you can use the image information to group that, and then like to tidy up in terms of what you believe are groups and that kind of stuff. But I didn't do any research into that area.
There was another question here.
Hi, I didn't quite pick up from your code examples. You were using NLTK and sklearn together, but I didn't. Can you say a little bit were you actually processing data with NLTK and then pushing it into sklearn? And if you were, can you say a little bit how that works? Because I've worked with both, but I find they use very, very different data structures.
Yeah. So in terms of the examples I was shown, I wasn't pushing information from NLTK in terms of where you're tagging words or anything like that into the sklearn. So the only thing that I was putting into the algorithms is the matrix of the words, or the bag of words collection. So I didn't do any processing with the NLTK to feed into that.
More questions anywhere?
So was it possible to use other features as predictors, for example, size, shape, image, color?
Yeah, so in terms of the classification, what I showed here in the presentation was the description in terms of could you build out the classification with the text and the description, and you get 72%. Like when you use the user report and somebody's consumed it, you can bump that up to 90%. But I suppose in terms of building out sort of a use feature maybe on the website in terms of feeding into different features. When I fed more to stuff in, it didn't have any sort of impact on what I was able to get at the start. But I think in terms of the sort of some of the motivation for this is that it's sort of being used as a learning example for people starting doing Python and scrape and all that kind of stuff. So I didn't do anything with creating bigrams and then trying to see how that would impact.
Hi, quick question. So I've heard a lot about Scrapey recently for web scraping. I noticed you use URLlib2 in Beautiful Soup. Are you familiar with Scrapey? And if so, can you say why you didn't choose it, or sort of compare the options?
No, I'm not familiar with it.
That's a fine answer.
Okay, I do not see any other questions, so let's thank the speaker again.